and you're welcome to start.
Did anybody get the verification? There it is. Okay, great.
Yes, we can see.
Can everybody see the screen?
Yep. Yes.
All right, great. Well, thanks for joining us today. We're the geoanalytics team. We are a group of graduating seniors at Washington State University, and we had the pleasure of working with our Microsoft team on developing and working with satellite imagery. And with a couple of their tools, we were able to work with that to create an application that's we think would be useful, and we want to present it here today. It's been broken up into three components. We have Molly Morris and Sean Roberts. We're going to start us off today with the first component, and Peng Yu and Duash are going to do the second, and then I will finish up with general presentation and the third component, and we'll open it up for more discussion and questions. And thanks again, everybody, for your help this semester. I think we're all very appreciative of your time and efforts, and really thanks.
Okay. So for this portion of the presentation, we will focus on the conversion features of GeoTIFFs in the Python application that we have created. This portion of the project was led by Molly Morris and myself. Can you switch the slide, please? In implementing this feature, Molly and myself set out on a roadmap for what we wanted to accomplish by the end of the semester. Our primary goal was to ensure that a user of our program would be able to easily import a GeoTIFF they had already had into our Python application. As GeoTIFFs are large multiband images, they are not viewable by typical image viewers. This means there has been no way to view the image in VOTT as of present. We need to implement an application that would allow us to render the TIFF before we could begin to tag it. We had to make sure there was a way that the GeoTIFF would appear for the user without losing any clarity within the image itself. Another important aspect of the project was creating a way to use the GeoTIFF images inside of VOTT. This tagging tool was particularly useful for our purposes as we had to be able to tag important aspects of the GeoTIFFs, so we needed to find a solution that was compatible with the existing software in place. As it stands, there is no way for the JavaScript application of VOTT to render a GeoTIFF in a canvas object, as it would be either a PNG or a JPEG. So this was the problem we were tasked with. After exploring solutions in JavaScript that appeared to reach dead ends, we decided that exploring the use of an alternative application to use in concurrence with VOTT would be more valuable with our time. This application takes the GeoTIFF as an array, which is then converted bit by bit into a PNG, which is then compatible type for VOTT. This allows us to create tags that are saved in a VOTT project. Finally, we thought a valuable feature to include would be retrieving these tags from the VOTT project and rendering them over the original GeoTIFF in our application. This way we can directly see how the conversion affected tagging. Could you switch the slide, please? This led us to mapping out specifically which features we need to incorporate into our conversion tool. Already we knew that we had to have a way to import these GeoTIFF images into our application and then into VOTT. This is presently done in our application both via an import and an open button within the Python application. As I have described earlier though, GeoTIFFs are not an accepted file type for VOTT, so we need to come up with a workaround for that. The implementation that we decided to go with for making sure that VOTT can load GeoTIFF images was to convert these images into PNGs. Once the image has been successfully imported into our Python application, our application needs to be able to successfully save a GeoTIFF as a PNG so that it can be imported into VOTT to then be tagged. Once the image is tagged and the tag information is saved locally, the Python application should then be able to render these tags over the displayed GeoTIFF image in the application's canvas. Slide transition, please. Our application was developed using the GUI Python library tkinter. This allowed us to add buttons, menu items, and slots for user entries when appropriate. When initially clicking on Import or Open, a file browser is launched in order for the user to select the geotiff they would then like to import. This file viewer only allows for the selection of TIFF images, helping prevent user error. In order to render our geotiffs, we also use the matplotlib Python library, which we then embedded in a canvas object inside the tkinter application window. In order to create more natural looking images, we use the function that Peter provided us last semester to adjust for gamma and percentile in the images. This was done by extracting the image as an array, isolating the RGB values of the image, and making the appropriate adjustments to the color scale. As we are working with multi-band images, these adjustments need to be made to the various bands in the image. When converting to PNG, we take these arrays containing the image information and use this to convert the geotiff to a PNG. This allows us to preserve each bit of the information when we make the conversion, of the image when we make the conversion, resulting in a negligible loss in bytes. Therefore, when the images are tagged in VOTT, they can accurately reflect the detail of the original image. The function that we use to do this conversion is imsave or image save, a member of the matplotlib library, which takes the raster data of the RGB array and adds an alpha channel, which simply ensures that the image is set to full opacity. When the PNG is saved, it is located within the folder where the geotiff came from and is named figure underscore a number, where the number corresponds to the latest option. We also prevent overwriting existing PNGs with a similar name in this. Finally, for our implementation of re-rendering the tags, we need to parse the given VOTT project in order to retrieve the appropriate tags for the given image. Because tags are stored in a JSON file in VOTT after they have been created, this meant our application would need to parse the JSON file to find the tags. Luckily, Python has a library which allows us to do this with a fair amount of ease. When the render tags option is selected in our application, the user will once again be prompted with the File Explorer, which only allows for the selection of JSON files. Using the coordinates from VOTT, we then render polygons over the plotted geotiff and labeled them with the appropriate tag names. Can you do a slide transition, please? In converting the images, there was some overall acceptance criteria we wanted to ensure was being met. This acceptance criteria helps us determine that the geotiff was converted to a PNG image successfully, and to confirm that the information was not being lost in the process. We need to ensure that the dimensions of both the geotiff and PNG would remain the same after the transition. This later will be shown in the demo portion that Molly will be running for this portion of the project. Additionally, if the dimensions are equivalent, every pixel in the PNG's array should be compared with every single pixel of the geotiff array to ensure that they are equivalent. Slide transition, please. So this is an example test that we did in Jupyter. It should be worth noting that when saving arrays as a PNG using matplotlib's built-in image save function, that if an array only contains RGB bands, the image save function will add an extra A band onto the end to make the PNG an RGBA image. This doesn't have any effect on the overall presentation or testing of the image, so this band is removed during the testing. Below, I have an example test output that was conducted in Jupyter Notebook. While there is a separate unit testing file for this application, I opted to have this example in Jupyter so that I could easily show the output to you all. On the left-hand side of the screen, we converted a geotiff image to a NumPy array to represent all of its RGB pixel data. On the right-hand side, a similar operation was performed to create a NumPy array of all RGB pixel information with the A band removed, using an already converted PNG image from our application. For simplicity's sake, I created a rudimentary acceptance test in Jupyter to show that after representing both the geotiff and PNG as pixel data in NumPy arrays, every single pixel will then be equivalent. And as you can see on the right side, it compared every array entry and showed that they were equivalent. Now we will move on to the remaining portion of this section, which is the demo being conducted by Molly.
Alrighty, so this is what our application looks like at startup. And if you click File, there's an option for Open. And the same operation can be done with the Import button. So here we open it, and as you can see, there's only geotiffs as options. So I'm going to open that. And this will take a moment because these images are very large. I believe this one is over 1 gigabyte. So it does take a moment. There are a couple features that we eliminated from the map plot because normally a map plot has, coordinate axes and stuff. So it kind of shows the height and width of the geotiff. And I thought for the purposes of our project that this was unnecessary. So I eliminated the axis, the X and Y axis. And then there was also a toolbar, which had some features that may have been helpful. But one of the options was to save the image as a PNG. But that did, the way that that was being converted did result in a loss of pixels. So we opted to remove that. So here you can see that the image is rendered. And if you go up to File, we now have 2 more options, Save as PNG and Render Tags. And the purpose of that becoming available after the image has been opened is to prevent user error, because in order to do those other 2 operations, we need to make sure that the image is loaded first. So this again does take a while because it's converting pixel by pixel. And in future versions of this application, it would be ideal to improve that functionality through threading or multiprocessing or something of that sort. So once this loads and it has saved as a PNG, there will be a message that says where it was saved, the name that it was saved under, and also letting the user know that they can now use this image in BOTT. So here we have geotiff saved at the location and that you can use it in BOTT. And this lets the user know that now they can work outside of our application. So first we want to check and make sure that the image was converted correctly. So we go to the place that we saved it and we open the image. And I apologize that it's a little blurry. I think that had something to do with my recording tool. But I'm going to go to the file info. And as you can see there with the dimensions, it's 10,980 pixels by 10,980 pixels, which does reflect the size of the original geotiff. So now I'm going to open BOTT and start a new project. And I name it, I believe, test geotiffs. And the source and target connections I set to the same place, the place where the geotiff and the PNG are stored, just for simplicity, for the sake of the demo. So I save the project. And this does take a moment to load in BOTT because of the size of the image, but as you can see there, the pixels are listed. And those other unable to load assets, that's how a geotiff would normally be rendered in BOTT, which is why you can't use them directly. So I'm going to create a few tags to use as examples. So I have a tag for clouds and a tag for farmland. And here I am tagging the clouds, just to give kind of a little overview of what that will look like once it's rendered in our application. Just wanted to create a couple little tags. And then there's a square of farmland at the top that I also wanted to tag. And now we have to save the project. And once we're happy with our tags and we're ready to use our application again, we can go back to our application. And I wanted to minimize some tabs just to make it a little easier for you guys to see. Again, I apologize for the blurriness of this portion of the video. So now we open the rendering tags and you're only allowed to select a JSON file. And then the tags are rendered and they are labeled appropriately. And now we can see that we can open another geotiff. And as you can see, the message from before of where the PNG was saved is now gone, as it's no longer relevant. And this will take a moment. I believe this one was 1.4 gigabytes, so it does take a moment to render the image. So ideally, when this is happening, we want to make sure that we clear out the old canvas image that has the old geotiff loaded, and we want to make sure we clear the tags as well, which is done when you clear the canvas object, because those tags are no longer relevant to the current project. So this is the new rendered geotiff, and we are going to save it as a PNG again. And this is to demonstrate that once it's saved, as it's saving automatically under the figure names, the first one was saved as figure 1. So once this one is saved, we wouldn't want to save it as figure 1 again because we'd overwrite the other PNG. So what's happening right now is that we're checking to see if figure 1 exists. And if so, we move on to the next one until we have an appropriate file name to save this one. And again, it's going to convert pixel by pixel. So that does take a moment. But it should save in the same place as the geotiff that you imported, which again is in that same folder. So you'll get a message explaining where it's saved and that you can now use it in VOTT. So once again, I will go to the image info. As you can see now, it's figure 2. It is blurry in the video, but it does render just as clearly as it did in the geotiff. And the file info, we can see again that it is 10,980 pixels by 10,980 pixels. So that concludes the demo for the importing TIFFs section of our project.
Thanks, Molly and Sean. That's great. So now we're going to have Pengyu and Duash.
Hi, so for panning and zooming section, Pengu and I worked on it. Can you click next? So there was this pan zoom React library that we were using in the beginning to implement the panning and zooming feature inside VOTT, but it was giving us all kind of scaling issues and did some dependency issues, so we couldn't use it. So we decided to go forward with the VOTT Canvas tools library to implement the zooming in and zooming out and panning feature. And as you can see on the screen, that you could zoom in using the toolbar button, and then you could pan on the asset either using your mouse wheel, or you could click on the scroll bar on the side. Next, please. Here's a little demo. Play. Yeah. So once you click on plus, it zooms in from the middle, and then you could also scroll using your mouse, and then use the scroll bar at the bottom, and then you could select a region to apply some tag. But we're encountering some issue with selecting a region and applying tags. I think you can explain more on that on the next slide. But here, when you zoom out, it stays within the scale. So, yeah, and Peng can explain on the next slide. Can you go next, please? All right.
Yeah, so when we switched from the pan zoom library to the updated version of the canvas tool for the VOTT, the canvas tool changed the way it interacts with the selected region that is it's not able to transfer the data from the VOTT to the Canvas tool to manage the inside state of the application. So the state manager is not able to access which region is selected, and that's the current big issue where you cannot interact with any of the regions except for moving them, and that's about it. And so we have a few fixes that we envisioned, but we were not able to implement them. So we can work from either side. We can try to change how VOTT interact with the Canvas tool, or we can try to update the Canvas tool to get the data from the VOTT correctly. And I think either one works, but we weren't able to implement those. And for the testing, we have a few cases where we can zoom into we can zoom in and zoom out, see if the zoom scales are the expected ones, or we can see if the zoom in will zoom beyond the limit. So currently, by default, the max zoom scale is 10, which means you can zoom in 1000%, and you cannot zoom out of, like, you cannot zoom more than the original image is. So you cannot zoom out to have a smaller image than the original one, because that wouldn't be applicable for the tagging purposes. And we also test that if the tags are retained. I think that's a big part for zooming in and zoom out, is that to retain the tags you applied before, so that they are up to scale, even when you zoom back out, or when you just save the project and the tags information while you are zoomed in and zoomed out. And yeah, that's about it.
Thanks, Benny and Dwash. So the final component of our project was to implement a machine learning component to our project. And the overall goal of our project was to create a data pipeline for being able to generate data off of satellite imagery, and specifically in the agricultural space, because of the idea that it's difficult to generate data in agricultural, since we're dealing with rural areas, and a lot of the times it costs a lot of money to create these data pipelines. But if we can use satellite imagery, imagery is open source and free, easily provided, and so if we're able to create a data pipeline from satellite imagery to useful data information on those images, it could help tackle some of the issues in agriculture. And so for our project, the first two components are useful tools for creating this data pipeline, being able to use the satellite imagery, and then being able to access areas in the satellite imagery with the panning and zooming. But for the third part, the goal of this part of the project was to create automatic tagging of the satellite imagery so that we can create that data pipeline. And the data pipeline is encompassed by the visual object tagging tool, which we've gone over, which allows someone to tag parts of images in an image. And so for our project in the machine learning, we're looking specifically at tagging cloud areas in a satellite image. So with the thought that in agriculture, it might be useful to identify areas of cloud coverage over time, or just to generate that type of data. And so the goals of this part of the project is to be able to interact with VOTT with the pipeline by importing the tag sections of the satellite imagery as training input into the automatic tagging, and be able to use that as training data to build a convolutional neural network that does object recognition. And then as a added component to this is to export that information back to VOTT for correction, as it's not always incredibly accurate. So to do that, we added a couple different, we used the MASK region-based convolutional neural network. This is a deep learning object recognition model that was developed by a group of Facebook researchers in 2017. It's an open source. There's also a module for it that I used for that's an open source project. The big thing with this is that it implements this idea of masks. If you see in the bottom right image, you have this image with these bounding boxes, which region-based convolutional neural networks generate and tag. But with masks, they create this finer bounding polygon, which would be useful for us since we want to be able to import not just bounding boxes but regions. Sadly, this isn't something that was fully implemented, but we'll be able to see the results in the next slide. Another important aspect of using this framework is that it uses transfer learning of pre-trained weights for the model. So the accuracy, you can use just a selection of images, as I'll show you, for coming up with some kind of automatic tagging. And then I'm going to do a video here. Let me know if the audio does not come through.
I don't hear anything, so.
Okay. So let me see if I can fix this. Otherwise, I'll just
Yeah, when you share your screen, you have to make sure to click the button that says include audio.
Okay. Let me reshare. Okay, great. For our project, we created an application that helps to establish a data flow between VOTT
Perfect.
and tagging application. And the way that this occurs is by setting up some mutual connections between VOTT and application, which corresponds to the folders in which VOTT operates. For our application, there's 3 buttons here that will establish those connections and ask for the folders. But before we do that, let's move over to VOTT and see how it corresponds as well. So if we're to want to do some automatic tagging for a single label, we would want to create a new project, name it, and assign and add connections to add the connections corresponding to these folders. So for instance, with what we're doing, it would be these images, project, and data folder. And once you've done that, you'll save the project, which I've already done. And when you do that, it loads the images from the source connection folder. And as you see, we have these 5 images where we're going to be labeling clouds. So what we would do is we would just go in here and label these clouds. And for our purposes, I'll do some crude labeling. 1, 2, 3, 4, 5. Let's do a large one for cluster. 6. Important thing to note with VOTT is that it only creates JSON objects for images that are tagged. So if we want to test this image, do an auto labeling of the clouds, we do need to label one of these clouds, or just create any kind of label. And once we've done that, we will export the project into the target source folder. And we'll access that folder real quick. we can see the images. This is the source connection. This is the target connection with the 5 JSON files corresponding to the tags. If we open one of them up, we can see SAT4 has 1 tag and the bounding box with the points. From here, we will coordinate this with our application. Since we've set up these folders, we will select them. So we'll select the images folder, which is the source connection, the project folder, which is the target connection, and the data folder. And this is used just by the application for housing some model information. Now from here, we would want to import the tags for use in training the model. So we can do that with this button here. And we can see that we have the 7 images, the 6, and then the 1 test image as well. And the functionality for this is to expand into multi-class auto tagging. If there were multiple classes, we would see multiple lines here, and we could click the ones we want to train on, and it would only tag those. However, right now, as I'll explain later, we're only doing the single classification. From this, we would press the train model button, and that would train a mask region-based convolutional neural network, and it will save the weights to that model into the data folder. The important thing to note is that even when we're only working on a small amount of images, this mask model is still useful because we're using transfer learning by initializing the weights to the weights generated by models that have been used on vast amounts of image data. And I will not, for the sake of the presentation, I won't press this button since it takes quite a while to train a model. However, at this point, we can still predict an image because I have saved into the data folder this file, which corresponds to the weights of a trained model. When we predict the image, it grabs the most recent H5 type file from the data folder and establishes a model to predict on those weights. So let's do that on the satellite too. As we can see here, this is the result of the region-based convolutional neural network. It tries to establish a number of different cloud regions for the image that we fed it, with the bounding boxes and the masks corresponding to the actual regions of the image. The mask, my understanding, is a matrix corresponding to the image itself, with 1 values for the actual pixels that cover the region, and everything else false for not doing it. So that's how it creates this this polygon or this region that is being tagged. Along with this, it gives a confidence on how much it believes that it is an actual cloud, and it creates a nice visualization. Now, along with this, we want to re-image this into VOTT because we want to be able to correct the tags and see them in VOTT. So what we'll do is we'll press this button to export the tags to VOTT. And what this does is it actually replaces the JSON file with the corresponding SAT2 image, and VOTT will re-image that into VOTT. And here we can see that these correspond to those same same areas. However, I will mention that we did exclude some of them that didn't meet the confidence interval that we wanted. And that's the functionality of the application. Great. Well, so as you can see, the output of this particular model isn't very accurate, but it does kind of show that there is a data flow going on between VOTT and our application. And I think primarily with this, you didn't see the original tagging. The original tagging wasn't the 6 or 7 images. This was just different. I think there were like 30 or more images, but I think essentially the input tags weren't so great for the training data. So that's why I think the accuracy is pretty low, but I think it still shows that it is applicable to, still useful for our purposes. Go back to this. Sorry. Sure I don't jump over it. So to talk a little bit more about the application, so we really want to be able to do the polygons, not just the bounding boxes, the rectangles for the tagging. So kind of future work would be integrating that into the data flow. So particularly this would be, I think this can be done, just more time to verify that it can be done. The other thing that we wanted to do as well is we don't want to just have for just one class. We want this to be a multi-class application. And in order to do that, there's a specific function in the module, the mask RCNN that prevented me from doing this, and it was my inability to overwrite the initialization class for this configuration file, which takes the number of images and the number of steps and an epoch, and that's something that I just ran into a wall with. Other than that, the other things that I would, if I had more time, if we're working on this further, I'd love to be able to utilize using my GPU instead of CPU with TensorFlow. It took, so for about 30 images, it took about 45 minutes to an hour to do just on the CPU, if I'm understanding how TensorFlow works. But on the GPU, from reading online, it should take 5 minutes or less. And then there's an important thing to mention with using this is that it was a big headache with using TensorFlow and the Keras library for the underlying machine learning components to the module, just because the last upgrade version to the mask module was in 2019, and I don't think they're doing it anymore. So it only works with, my version only works with TensorFlow 1.13. I think we're on TensorFlow 2 point something right now. And along with the Keras libraries, it uses a deprecated version. And you can refactor it to TensorFlow 2.0, but it takes a lot of manipulation of the module. But that's something I think we'd want to do in order to have this up to stuff for actual use. And just a little citation. I just want to, the mask RCNN is open source, so I think it's important to have that on there. Also got some great coding help from there's a doctor in computer science that wrote an article on using this, so I'm going to put that there. And with that, it kind of concludes our project presentation. We'd like to have any kind of feedback from the team here, any kind of clarifying questions, or to show you more of the application if you want. But thanks again for everything.
Yeah, so let me start with a couple of questions. So the reason that the accuracy was a little low on the machine learning method, is that because there wasn't enough annotated or enough accurate annotation, or?
I think it might be, it's both. So for instance, with this cloud, so this is the type of image input that I'd use. And I wasn't really certain, if this is objective for this image, because you could say this whole thing's a cloud, right? And then feed that in. So I wasn't really totally sure how to tag clouds, especially with something like this, because you can say that this, this part is a cloud, right? But the whole thing's like a cloud cluster. So my thoughts were that, it's the CNN should be just recognizing, the boundaries of shades of white over this image, and should be able to interpret a cloud like that. But I wasn't too sure. So I think maybe my labeling may have resulted in the accuracy being pretty low.
Yeah, I think you need to annotate all of the image in terms of clouds and have accurate boundaries.
So that was my other thought is that, if I only tag these amount of clouds, I wasn't certain if that would send the wrong information that these are not clouds to the model.
Yeah, it definitely does send the wrong signal.
So
and one point on the GPU, by the way, is generally it's very, very difficult to get the GPU set up with TensorFlow. Yeah, it's you have to find the right instructions online, otherwise you're gonna spend hours and hours.
Yeah, I looked into it and it was, it seemed like that.
And generally you can get, depending on the GPU that you have, you can get as much as a factor of 100 speed up.
Oh, really?
So.
Yeah, I had to turn off some of the features in the module because they were they had defaulted variables to use like multi-plot processing, and that just wasn't working. So I ran into a lot of issues, I think, with that kind of thing. But I was really glad that I got to work.
Riaz, Wallace, do you have some questions?
Yeah, so overall, I think you all did a good job. I am aware of the issues that you were facing with VOTT in integrating the pan and zoom. Unfortunately, there looks to be a bug inside the Canvas tools portion of VOTT, which is developed by a separate subset of Microsoft employees, and I wasn't familiar enough in that area to provide guidance early enough to have the team finish in time. So, but I think they were well on their way of getting that resolved. I think they did a great job of implementing the toolbar and the pan and zoom there, and upgrading to the latest version of Canvas tools. So good job across the board there. And yeah, overall it was very cohesive. I liked how your standalone application was able to integrate into VOTT, basically leveraging the file system underneath as the backend data store between those components. So that part flowed well. Yeah, and I think the overall struggle with these GeoTIFF images is that they are so large in size, right? So we did see some loading delays and saving delays because you're dealing with images that are, hundreds of megabytes or if not gigabytes. So it's a difficult data set to work with for sure.
Yeah, I think the typical GeoTIFF that we had is about a gigabyte. So no worries there. Riaz, do you want to make some comments?
Yeah, actually, I am very happy, impressed with the work that has happened here, right? I know I had seen way in the early stages of the conversation, though I didn't attend most of the middle section, but I am happy to see the progress you guys have made here and be able to also integrate some of the model pieces which we were initially talking.
Right. So I guess I can also pipe in and say that the final product looks very good. There's a lot of moving parts, so impressive that you got it all together. And now that you have all this great stuff, how do we get it?
That's what actually wondering that. So
Yes, I had the same question myself. I was going to ask you guys how you'd prefer to do that.
So
Yeah,
what will this be integrated in the open source? Some pieces of it?
Yeah, so the additions to VOTT, I know that the team was working off of a fork of VOTT and contributing back to there. So that's one way that we could, get the updates from the team is to leverage that fork. One thing I would recommend there is to maybe just open a pull request so that your changes from the fork can flow back into the main VOTT repository. And if you're willing to, the other aspects of the project as well could potentially just be stored as open source up in GitHub, as long as the team is comfortable with that, and then that would allow us to be able to pull it down and leverage it as well.
Yeah, I think that would be great. That's a great suggestion.
So I had a lot of issues with getting the mask module to work. So imagine the documentation. I need to, let you know what versions to use and things like that, right?
Yeah.
Okay.
Yeah, so typically I think so. All of that was a Python project, right? So are you leveraging like PyPy packages in there? And do you have what is the file within Python called? It's like a requirements.txt file, I believe, that lists all of the dependencies, or is there more to it?
TensorFlow tends to be a little more involved.
Okay.
Yeah.
We will be including a README with our project to kind of go over some of the other dependencies and things like that as well. So a kind of an outline, a loose outline as well of some of the functionality and stuff like that. So we can be sure to include that with our project when we submit it.
Wonderful.
And I think we'll. I'm not sure when we're required to submit it, but I think it's because we have to submit the presentation today. But I think we can submit it later. But so I think Sunday, probably set something up and make sure it's sent over.
That way we can get the documentation out of the way.
Yeah.
Fully.
Does that time frame work for everybody on the Microsoft side?
Sure.
Yeah, that works.
Cool.
Great, fabulous.
Yeah. Yeah, thanks again for all the hard work. And if nobody else has anything, I guess we can stop the recording and...
Yeah, I was just going to say awesome work and good luck for your future endeavors since you're all graduating now and will be in the workforce.